Hello everyone, let's talk about another easy problem on Leetcode today. Island parameter Leetcode 463. It states that given a row into column grid representing a map where grid ij means when grid ij is 1 represents land and when it is 0 represents water. Grid cells are connected horizontally and vertically and not diagonally. The grid is completely surrounded by water and there is exactly one island. Um, and then it says that uh, the island is the group of one or more land cells. The island doesn't have lakes, that is, there is no water inside the island connected to the water around the island. One cell is a square of side length 1. The grid is rectangular. Width and height don't exceed 100. Determine the parameter of the island. And then it shares a very good example. So all these yellow lines actually mark them as the parameter which counts, and the black lines are the ones which is not counted. So all this brown space is actually an island. So then for example, from this cell we can see that okay, only three sides are counted. From this one also we have only three sides, likewise for this one. So we have 9 total so far. And then from this cell we have only 2 sides. Again from this cell we have another 2 sides, so it becomes 13. And eventually from the last cell we have 3 more, so it's in total 16. When it comes to parameter here, they are not asking for area but just the parameter. And what we can see is, like, when we talk about parameter, we actually are coming from the water to the land. That's a crucial point, I think, when we are calculating parameter. For example, this land mass which is here does not have any water to its sides. I mean, we can't count diagonally, so that's why we can't say there's a water here technically. So that's why this side is not at all counted. Now with this hint in place, let's now jump into the solution space. Now that we have understood the problem, let's try to understand the solution. So one of the solution is like simply iterative solution. So think of this land cell as a square, just as a single square in the water. So in this case, what will happen is, like, all the 4 parameters will count, all the 4 sides will count. So we will add 4 to the parameter, right? Um, but if we have a land cell next to it, say one below it here, right? So in this case, we subtract 2. The reason is we are wasting 2 sides in 2 different squares, right? So we can't count one side in this one here, this square, and also in this square. So what we will do is, like, we will subtract -2. Similarly, if we have another cell right to it, we will again be wasting 2 sides, right? Because again, there's not only one side wasted in one square, but because there are 2 squares getting connected, we subtract 2. And as soon as we come to the right or left, depending on how you see it, we can start calculating the parameter accordingly. Also, now the question is, like, why we just care about the squares on the right or at the bottom? Because we will be traversing on this matrix or grid row wise and column wise, and these are connected in 4 directions, right? Up, down, and left and right. And because we go from left to right, we have already taken care of the left nodes, right? So but we are now taking care of the right nodes, so that's why we subtract -2. And similarly, we come from top to bottom, so we have already taken care of the top node. Now we are in the future taking care of the bottom node. So that's why we are calculating it this way. So let's look at an example here. So we are at grid 0 uh, or grid 0 0, right? So in this case, it's a water, so we don't care about it. But then we go to the next grid and we see, okay, it's a land, right? So we add 4 to the list, but we also see that it has one land square which is just below it, so we subtract 2 here. So we are subtracting 2 here, but when we get to this grid, we will again add 4, just to be what you say fair to the next grid, right? So we can also subtract -2 in the future, but let's stick with the current algorithm. Then we finish the first row, so we don't find any land anymore. So then we come to the next one. So far the parameter is 2, right? But technically it should have been 3, but we will see how this plays out, because this algorithm looks at the island in totality. So then we again find a new island, right? And because it has bounds on the side and everything, we again count it as 4. But we see that this island on the right has a landmass, so we subtract -2. uh, then we look at next island here, right? So in this case, because we have already taken care of the top island, right? Because we are coming from top to bottom, we don't have to worry about it anymore. But we do have to worry about one on the bottom and one on the right. So in this case, we will again subtract -2 for right and -2 for bottom, right? Then we go to this island. Here we can see that, okay, we have 4. We will just add 4 here, but on the right side, we don't have to worry about. And for the left side, we have already taken care of with this -2. Now, once we are there, now we come to the next row. We see again water and then eventually land again. So we have 4 again here as addition. But at the bottom, we see one more land square. So we just do -2 here. And then this row is also over because everything else is water. Then we have first row where again, sorry, the last row where we have, we add 4 again because it's a land. And on the right, we already have another land. So that means there's a loss of parameter here. So we will subtract it here. Then we again get 4 here. But as you can see that we have already subtracted -2 for the one at the top and one at the left. So we don't subtract anything anymore. And that's it. So now let's see how much is our parameter. So from here we get 2. From this one we again get 2. From this one we get 0 because this parameter is surrounded by all the sides. So far our total is 2. In this row we get 6 as a addition. In this row we get 2 more, and in this row we again get 6. So in total we get like a 16 as an answer, which is an expected one. But let's think about, can we use another simpler approach? I mean, this solution can work, but the trick may not always come to the mind. And for such grades, it's always good to think about it like a graph or something, because then you can play around some good algorithms like breadth first search or depth first search. And this is what our solution is hinting to. So what we can see is like we can think of our what we can do is like we can start from some point in the island, right? And because there's only one island and it is connected, what will happen is like we will find uh, what we will do is like at any point, suppose it's like a mountain or something, and we are standing here and we are staring. We can stare either like in any of the 4 directions, right? We can stare at up, or like a north, or we can stare at south or east or west. Right? And if on any side we see a water, or there's a this base case where we are at the bounds, we will treat it like a water. Then we will just add 1 to the parameter, right? And um, if we see a land, we don't do anything. In this case, what we will do is like once we have calculated the water we have seen in the current cell, we will add it to the visited set. And then we go to the next adjacent land cell, see again repeat the same algorithm multiple times till we reach the end of our like all the land cells which we have not uh, uh, visited so far, and now they are all in the visited set. So this is how the algorithm looks like. So let's now jump into the what you say dry run part. Now let's look at how DFS will work. So the first thing is like we will again start with somewhere in the land cell, right? And what we will be doing is we can suppose we are at this land cell now, and we will try to go into the adjacent cell, like in the four direction, right? Up, down, left, and right. So, yeah. And what we will be doing is like we will be seeing if we are on the land cell and we jumped into the water just to check it out. Of course, we can see that, but let's jump and see if it's a water, then we will just add one to the parameter. And otherwise, if it's a land, we will repeat the same algorithm again. So suppose we are on this land mass now. So we can see we can either go into the four directions, right? From this one. So if we can go to this direction, that means we add one to the parameter, right? Uh, if we can go to the right, we see water again. So we add one more, and we see on the left again there is a water, right? So we add one again. And now we come to this landmass, and in this case we can't do anything here but just go there. So now we will add this to the visited set. So suppose this edge is called like 0 1, right? Now this is in the visited set now. And then we go to the this landmass. Again, we can go in four directions just to see if there is a water. So on the left side, on the top or towards the north, there is no water. South, no water. East, no water. And west, no water. So we will just mark this cell as process as well, right? So it will be 1 1. Now add it to the visited set. And suppose now we go to this cell, right? So in this cell we will see, okay, on the left there is water, so we will add one here as well to the parameter. On the right there is a land. On the top also there is one more water cell, and at the bottom also there is also one more water cell. So this solution is very intuitive, right? Because now we at each square we can see that there's a water, and it actually resonates with our view as well, because we can see there are three sides where we can see the water, and this is what this algorithm is doing. Now from this one we can either go back to this one, right? Or we can so we come back here, but this is already in the visited set. But one of the neighbors of this edge was also this one. So we come here again, we look at the three sides, and there is already a water. This side is already covered. It's in the visited set. So I forgot to actually add this one into the visited cell as well. So now this node is also in the visited cell. And now because we have processed this node as well, it adds 3 to the parameter. So we will again add this to the to the visited set as well. So it will be 1 2, right? And uh, one of the neighbors of this was also this one, right? So we will again do the DFS in this direction. So we come back to this node, come here again, and now we look at this side. Oh, there's the water, so we add one. And similarly on this side there's the water, so we will again add one. Now we will have two more added to the list. But when we look at the bottom, there's a new, so we can either go back to the top, right? But this is already visited, so we don't have to do anything here. But we come down instead, and this time this node is not visited, right? So for this one, we can either we can look at this side. There is only one water here, and on the left side there is a new landmass which we have not yet discovered. So now we add this also to the visited cell. So we added 2 1 earlier, and now we also added uh, 3 1 earlier, 3 1 now. And now this one is also, we can see there's a water on this side as well as this side. So we add 3 again to the parameter. And in this case we also mark this one as visited as well, right? So this will be 3 0, right? So now there's if we look at the as adjacent cell of this one, this is a cell now next to us, right? but this one is already visited. So now there is no cell which is land cell which is not yet visited at all. So we have reached the end of the DFS. And what we will be doing so far is like we must have been accumulating all the parameter values that we are getting from each step in the DFS, and that should be our answer. I prefer the second solution more compared to the first one, because first one is slightly less intuitive, and second one is slightly more generic and comparatively easy to solve in the interviews. Second thing is like the time complexity wise. First one is like O n into m solution. This one is O of what you say, uh, like again n into m, but it is more close to the land cells that are available, because those are the ones which we are actually traversing. But when we talk about the time complexity is again O of n into my m, with slightly better chances in the second approach. Now let's jump into the code part. Now let's solve this problem using DFS. So first thing we will need is, I think the first thing we can try is like creating the direction array, right? So we can either go what is it, top or bottom, right? So plus one means that we are going on the right side, right? Because we are moving from left to right. So dx means change in x, basically. And similarly, dy means change in y. So either we can go right, or we can go left, right, or we can go bottom, or we can go top. So this is what the dx and dy represent. Similarly, we will also create visited array, because for each element in the grid which is land, we want to know whether we have already processed that land mass or not. So we can keep it as is, because we don't know the size yet till we are into the function, and we will also need the perimeter, sorry, which will be our answer. So we will now initiate visit set. I think we can also create a hash set storing grid I and j. But for now, I will just create a Boolean array because that's easier. So what we will need is let int m be grid dot length and be grid 0 dot length. Now we will just create this new grid. Now the next thing we will do is like we will start searching for the landmass in the array and start the DFS from there. So we will just do, and similarly we will go column wise as well. Once we do that, now what we will do is like if the at any point we find out that grid ij is equal to 1, right? And it is not visited. I mean, most probably it will not be visited at all. But just to keep the logic sane, we will start the DFS from there, this point, and pass the grid as an input, because this is what will matter. Next thing we have to do is like once we have, because there is only one island, we can just break as well. Of course, if we loop, we will have a visited set, so time complexity will still stay the same, but adding it slightly optimizes it. Now let's think about the DFS function that we have. So one thing we need is like looking at the syntax. What we will need is like we will we don't care about the return value here. We just pass int r, int c at like the row and column at which we are at of the landmass we are currently at, and grid. Then what we will be doing is like we will be processing this element now, right? Because uh, we are here and now we will just process. So next thing we will do is like int I equal to 0, I less than 4, because these are the 4 directions we can go to. And similarly, we will calculate the new row and new column. So our new row will be r plus dxi, that is change in I, sorry, change in the x direction, and new column will be c plus change in new column, right? And as we discussed earlier, like we will increase the what do you say, perimeter, when either of these new row or new column that we are seeking is water, or we are at the bounds. But if it's a landmass, we will just process the remaining neighbors of that landmass. So then what we will do is like if new r is less than 0, or new column, sorry, not mu, new is less than 0, or new row is greater than equal to grid dot length. We have to do equal to, because like arrays are 0 indexed, or new column is greater than equal to grid 0 dot length, right? In this case, we will just do we will just increment the parameter by 1. Similarly, if I mean, we could have added it into the same place, but yeah, I'm adding it separately for the clarity here. So if new r or new c is equal to 0, that means we are looking at the water side, and we will just do perimeter plus plus again, right? In remaining condition, I mean, either I can put else, or I can just do the, because that's the only condition remaining. So I can just do if not of is did new row, new column, right? uh, we will we will just return what you say, we will just return true. I think we will just do the DFS, sorry. Yeah, actually I was thinking about, I have not yet initialized the boolean. No, I have actually initialized the boolean array. Okay, then all is good. Yeah, so that's it, guys. I think let's now test this code out. So it says missing return statement. Yeah, of course we have to return perimeter here. And now let's try it out. Okay, let's try it out again. I think, I don't know, it says exit with code. Let's do it again. Okay, it says class not found, island parameter. Okay, let me think about why. I think it has to do with my local environment. I think it's not properly set or something. Maybe I'll look into it later. But let's jump onto the Leetcode and see, copy paste this code there. I have copy pasted my code from Visual Studio Code to Leetcode for now. And now let's submit the code. There is actually a problem. We have to see why. So it fails in DFS on line number 33. So it says that index out of bound. Ah, I got it because I was thinking, yeah, it should be in the else loop, right? So yeah, because what is happening is like we are like if we are not in the bounds, what we are doing next is like we increment the parameter here, but regardless of the else condition, it comes here, but the index is out of bounds. So I think that was the bug in my code. So I think now let's try it out again. Cool. I think that that was the issue. So I hope you guys like the solution. If this video helped you in some way, please do share and subscribe. Have a nice day.